So my actual data is this here, of course, and the green bits are the uncertainties. So that is this part done, and now I'm actually transferring this information to LoggerPro. Let's go and do this. So LoggerPro, here we go. I'm going to put my, for x, I'm going to put 1 over the mass in, this is in 1 over m, and then or actually what looks even nicer is to say superscript minus 1, m to the power of negative 1, and the units is kilogram to the power of negative 1 as well. So here, that is my x value. For my y value, I am putting here the delta t, or change in temperature, and that was delta t, and the unit is degrees Celsius. So that is done, and you see this is what I'm getting here straight away. Now for my now I want to insert, for this data set, I want to add a new column, and this should be the change in the uncertainty in 1 over m, delta 1 over m, and the units is of course kilogram to the power of negative 1, and I'm doing this nicely to the power of negative 1. There we go. Okay, and then I need to insert another column here, and the other column is the uncertainty in average delta t. So this is one of the few times where you actually can say the change in temperature is you have the delta for the change in temperature and the delta for the uncertainty as well, which looks a bit weird. But never mind, that is fine. So now I just need to copy my data. So for 1 over m, I have this first, then I'm taking this, and now I need to be careful. This is the change in 1 over m. Then I have here my average delta t, and actually I could call this average change in temperature. Looks a bit better. And then I have here my uncertainty in that, and that goes in here. So that's that so far. Now I want to draw my now I'm going to draw my error bars. To do my error bars, I do the following. I go on the mass and I say under options, error bar calculations, and the error bar calculations I'm using uncertainty in 1 over m. And for delta t, I'm using the column, the uncertainty average delta t. So that's that. Okay, so my uncertainties in 1 over m are minute. My uncertainties in delta t are significantly bigger. Now I'm going to click on here. This actually allows me to zoom in a bit. Note that this is no longer the origin. Now I want to insert the gradient, and if I click on here, it allows me to pick a fit. So I'm going to go for the linear fit, and I'm going to say try fit and OK. So now I have the gradient here and the y-intercept. You see it's not 0 as we expected it to be, but slightly different. I can also say here I want this to actually start with the origin, and then I can see that this is actually not the origin. For my 1 over m, I'm actually starting at 0, so that works perfectly fine. Now I want to actually insert another 2 lines of best fit for a maximum and minimum slope. And to do that, I double click on here, and I go here, I go linear, try fit, manual, and now I double click here, I say enable line drag, and now I can actually change this here. And I can do this in such a way that it actually roughly fits what my maximum slope could be and my minimum slope. I can drag this across here, and I can then make another one, try fit, manual, and I can enable line drag on this one as well. I'll go back in here, disable the line drag, enable the line drag here, and now I can say this should actually match this. If you want to, you can actually make these appear in a different color. So for example, this could be in blue, and then this could be in blue as well, just so that we have the same appearance for both of them. Okay, there we go, and then you can see more clearly. Actually, if I look at this, I might actually pull this up a little bit more, because most of these are a bit higher, so this probably is a better fit. So there we go, and now I can say what my maximum and minimum gradient are, and that's it. So what I would do is, I would say for the gradient, you would go into the spreadsheet, and now you would say gradient m equals m equals, so 14.3 degrees Celsius kilogram, and delta m would be equal to half the range So that would be equal to 15.9 minus 12.7, 15.9 minus 12.7 divided by 2. And that would be equal to 3.2, so 1.6. degrees Celsius per degrees Celsius kilograms, and that would actually then mean that my gradient m would be equal to 14.3. Well, actually this should be roughly 2, and that is one significant figure. So to match them, I would need to have this plus minus 2 degrees Celsius. So this is my gradient, and the y-intercept I would do the exact same thing with. I would say the y-intercept is equal to 1.46 degrees Celsius, and delta y-intercept would be equal to 6.56 minus 3.47 minus negative 3.47 divided by 2, and that then makes roughly 3. Makes 6.56 minus 3 plus 5.015 degrees Celsius. So this would be roughly 5 degrees Celsius, and that is one significant figure. So that means that I'm actually ending up with a y-intercept of y-intercept is equal to 1 plus minus 5 degrees Celsius. So there we go.